PQRS is a trapezoid such that P, the coordinate is 1,3, Q 6,5, and angle PQR is 90. If R is on the x-axis and PS is perpendicular to the x-axis, find the area of the trapezoid. So let's draw a diagram. That's the new diagram. So from the equation, so they said PS is perpendicular to x-axis, so this is 90, making the coordinate of x coordinate of x to be the same as P. So this should be 1, common. Maybe let's call the y coordinate, we don't know. Let's call it F. YR, we don't know, we know the x, we know the y coordinate, but we don't know the x, so let's call it y is always this is on the x-axis. And for this to be a trapezoid, as you can see, this line is also parallel to this. Yes, that's the condition for trapezoid. It has one pair of parallels, and since this is perpendicular to PQ is perpendicular to QR, so the slope, the product of their slope will be -1. So for perpendicular line, the slope of PQ, let's use MPQ, is that of QR will be -1. Why? Perpendicular lines. Product of their slope will always be equal to -1. So what's slope of PQ? So we use changing wherever changes. So we'll have 5 minus 3 over 6 minus 1 times y. This is 5 minus 0 over 6 minus p. That's multiple times 1. This is 5, 5, 2. So we'll have this goes over, so I have p minus 6. Now we are left with 2 here. So see that p will be 8. Yes, so the coordinate of the s coordinate of r is 8. So to get y for what, that's for x, the y coordinate of vertex s. So as you can see, the lines are parallel. So we use that same property. That's MPQ. The slope of PQ will always be equal to the slope of SR. Yes, that's for parallel lines. Their slope are the same. So the same thing, the slope of PQ is from here, this is 2 over, so this is 2 over 5. Is equal to the slope of this. So remember, we've known the value of B, which is 8. So changing wherever, so I have A minus 0 over 1 minus 8. B is 8, so 1 minus 8. So solve for A. You see that A will be equal to this minus 7, so I have minus 14 over 5. So we've gotten the values of A and B. So let's now get the area. For us to get the area, we need the length. Yes, we need the length PQ, length SR, and length QR. So let's get the distance now, which is the length. So PQ, length PQ, using distance formula is square root of 6 minus 1 squared plus 5 minus 3 squared. That's using distance formula, which is square root of 29. Yes, but this is 25 plus 4. That's 29, square root of 29. Y SR, same thing. Square root of 1 let's 8 minus 1 squared plus 0 minus 14 over 5 all squared. And this is 7 squared. This is 14 over 5 also. And 14 is 7 times 2. So I can write this as 7 squared plus 14 is 7 times 2, so I have 7 squared, 2 squared, over 5 squared. So we are still correct, because I want to solve it faster. 14 is 7 times 2, so the square affects both. So 7 squared, 2 squared. Right, so if we factor 7 squared, square root of 7 squared is 7. So we are left with 1 plus 4 over 25. 4 plus 4 over 25. So 1 plus 4 over 25 will be 29 over 25, and square root of 25 is 5, so we're left with 29. Square root of 29 over 5. Yes, that's the simplest one possible. Y cubed the distance, the same, we still apply the distance for, which is square root of 8 minus 6 all squared plus 0 minus 5 all squared, which is also square root of 20. Right. But this is 2, 4, 4 plus 25 is 29. So we've gotten what we need for the area. Therefore, the area of a triprism is always half the sum of the parallel sides. So the sum of the parallel sides are PQ and SR. So this plus 729 over 5 times the height. The height is cube R, which is 20. And if you need, you can factor the 29 in both, yes. If we factor it, we are left with 1 plus 7 over 5. And 1 plus 7 over 5 is 12. 5. So this is 20. And 29 times 29 is 29. So I have half times 29 plus 12, 5. So which is equal to 2 in 12, 6. So 6 times 29 is 174 over 5. So that's it. Square units. So that's the area of this triangle. Sorry. Thank you. 3.1 verse 2.